All right, 11.3. So we're finding the area of a kite or a rhombus. Okay. So remember, it's a very simple formula. Whoops. Area equals 1/2 d1 d2. Okay. So you have your two d's right here, and then it's basically 1/2 19 times 38. And you just type that in your calculator, and it's 361 units squared. If you ever have an even number, you just take half of that. So it's basically 19 times 19 on this one. On this one, be careful. Distance is 12 and 12. Okay, so basically you're doing area equals 1/2 12 times 12, or 12 squared, however you want to write it. So half of 144 is 72, again, units squared, because we don't know inches or feet or anything like that. Right? 10 and 7, or sorry, 10 and 14. So 1/2, 10, 14. Half of 10 is 5. 5 times 14 is 70 units squared. Now, this one is a little bit of a tricky one. This is 6. We have no idea what this is. No hint. Okay, well, there's a hint. And the hint is, if this is 6, this is 3, and this is 3. Well, what we have here is a right triangle. So we have 3 here and 5 here. We need to find this. Two ways of doing that. A squared plus b squared equals c squared, or recognizing that that is a classic Pythagorean triple of 3, 4, 5, which means this is 4, that's 4, so that's 8. So area is 1/2 6 times 8, which is 24 units squared. All right, so the center of this polygon is P. It's also the center of the circle. Identify a central angle of there. Okay, so central angle and find the measure. So that is a little bit tricky because there's more than one angle. Here's a central angle. There's a central angle. Okay. So we're going to go with that one right there, NPM or MPN. So angle NPM. Now, how do we do that? Well, there's 360 degrees. This has 5 sides. So 360 divided by 5 equals 72, which means each one of those is 72, 72, and so forth. Okay? What's the radius of the polygon? All right. So the radius is right here, or right here. So basically 2 sides of that shape we just did, the angle we just did, and we know that's 5. That's PM. Or you could have said PN, doesn't matter. What is the apothem? Okay, well, the apothem remember, we're talking about the shape now, not the circle. So the apothem is right there. It's QP, and it's 4.05. Okay, find the measure of central angle given the number sides. So (360) divided by 10, simply 36 degrees. 360 divided by 18, 20 degrees. That's all you do. All right. One more work here to be done. So we have this octagon, A, B, C, D, E, F, G, H. And we're trying to find some angles here. So GJH, that is this angle right here. So that is one central angle, which is 360 divided by 8, which is 45 degrees. Now GJK, well, GJK is right there. The apothem is a bisector, so that makes this half of that, 22.5 degrees. KGJ. KGJ right there. Okay. Well, we just figured out, let's look at this triangle separately. We just figured out that that is 22.5. We know that's 90. So if we subtract this from the remaining 90, that gives us 67.5 degrees. And what about EJH? EJH. Okay. Well, that is basically 1, 2, 3 central angles. So we take this number times 3, and that gives us 135 degrees. All right, remember here, area is 1/2 the apothem times the perimeter. So the perimeter of the shape is 12 times 3, so 36. We know the apothem right here. So area is 1/2 2 root 3 times 36. So you can say half of 36 is 18 times 2 root 3, whatever, or half of 2 is 1, so it's 36 root 3, and that's your answer, 36 root 3. And you can just leave it like that. You do not have to multiply it out and get a decimal. Okay, number 20. So in this case, we have that right there. Okay. So we know it's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a nonagon. So to make life easier, let's just pull this triangle out a little bit. Now, first off, since it's a nonagon, 360 degrees divided by 9 is 40, which means this angle right here is 40 degrees. Okay. Now, we want the apothem, which is that line right there. Okay. We know this right here is 6.84. Well, if we take 6.84 and divide it by 2, that gives us 3.42. That means each of these is 3.42. We also know that this length here is 10. So, using one of two methods, we can do a squared plus b squared equals c squared. Okay, so that'd be a squared, well, I just reversed them, doesn't matter, plus b squared equals c squared. And when we do that, we get a squared equals 88.3. Square root both sides, and we get 88.3, 9.39. Okay, so the apothem is 9.39. Well, we have the apothem. We take this 6.84 times 9 and find out the perimeter is 61.56. Now we just do area equals 1/2 the apothem times the perimeter. And that gives us 289.24. Now, there was another way to find the apothem. You could have also used trig. So this angle would have been 20. We had the opposite side, or we had the hypotenuse, and we're trying to find this side. So we could have used trig to solve for the apothem. So for example, if we were going to use the opposite side and we're trying to find the nearest side, tangent of 20 equals opposite over the unknown. Switch those, and the apothem would be 3.42 divided by the tangent of 20. So if you did that, 3.42 divided by the tangent of 20 would have given you the 9.39. You could have also done the same thing using the 10, which is the hypotenuse, and the adjacent. So you could have used cosine, and actually even further, you would also know that's 70. So you could have used that with any of the numbers and used trig. So just another option to look into if you feel more comfortable that way. But quickest way would have been Pythagorean theorem. All right, so on the number 21. Similar idea here, except this time we need this side. So again, we're going to take our little triangle here. It's a horrible triangle. This is 2.5. This is 2.77. We're going to use a squared plus b squared equals c squared to get this piece, and that's going to end up being 1.19. I'm not going to show you. We've done that enough this year. So there's our triangle. Okay. So if that's 1.19, and we double it, that means we have 2.38 for each side. And there's 1, 2, 3, 4, 5, 6, 7 sides, which means our perimeter is 16.66. Okay, so again, recapping. We had two sides of a right triangle. We use a squared plus b squared equals c squared to find the third side, which is 1.19, which is half of the whole side of the shape. So therefore, we doubled it, got 2.38, and then multiplied by the number of sides, which again was 7, and there's our perimeter. We already have our apothem, so we're basically done. 2.5 times 16.66. I forgot the 1/2, so I'll put it at the end. And when I multiply that out, I get 20.87 square units. All right, not a lot here. Okay, we know we have a 1, 2, 3, 4, 5, 6 hexagon. So what we have here is a central angle of 360 divided by 6, which is obviously 60 degrees. So we split that. I'm going to draw it out here, make life easy. That's going to make this 30. That's 90, and that means this is 60. Okay. Now what do we have? We have 7. This is 7, which means this is 3.5. On a 30, 60, 90, and that means we know that this is also 7. And the apothem is just simply 3.5 radical 3. Because we're going from the small side to the medium side, we multiply by radical 3. So our perimeter is 7 times 6, which is 42. Our apothem is 3.5 root 3. So the area is 1/2, 3.5 root 3 times 42. That's 73.5 root 3, which is acceptable. or 127.31 units squared. Okay, one of the last two. So we need to find the area of the shaded region, which is simply the area of the triangle minus the area of the square. All right. So in this case here, we have a central angle of 90 degrees, 360 divided by 4. Okay. So what we have here is this 90 degrees. Split that down the middle. Now this is 90. That and that are 45. So we have a 45, 45, 90 triangle. Okay. So if this is 14, then the legs are 14 divided by root 2, which we have to rationalize. So that's 14 root 2 over 2, which means 7 root 2. So that means this right here is 14 root 2. Not root 0.2, root 2. All right. And that's 14 root 2. So the area of the square is 14 root 2 times itself. So 14 root 2 gives us 392 units squared. That's the area of the square. Okay? The area of the circle is pi r squared. Well, the radius you can see is 14. So 14 squared times pi is 615.75. So again, that was 615.75. So if we subtract those two numbers, we find out the area is 223.75 units squared. Same idea here. Area of the circle minus the area of the triangle. Okay, so again, we're going to do this. Right there we have a central angle. So 360 divided by 3 equals 120. Okay, so this whole thing is 120. Sorry, I got ahead of myself. That's the central angle, it's 120. So this one, for the smaller triangle, again, that's 60, which makes this 30 and 90. Okay? Which makes that 8. So the area of the circle is easy. This is the radius. So area of the circle is pi r squared. So 64 pi. And then to find out the apothem, which is right here, that's the small side. So you're going from the hypotenuse of 30, 60, 90 to the small side. You simply divide by 2. So that's 4. And that makes this 4 root 3. And now why do we need that? Because we need the perimeter of the triangle. So if this is 4 root 3, that means this is 8 root 3. And there's 3 sides. So the perimeter of the triangle is 24 root 3. So the area of the triangle is 1/2 the apothem, which is 4, and the perimeter, which is 24√3. And when we type that out, we get 48√3. So basically we have 64 pi minus 48√3, which we can just type in our calculator. And we get 117.92 units squared.